In this video, we are going to present all the inputs contained in the JPAD Modeller Sizing Plot Data tab. This is the last of the three subsections of the pre-design input module. The sizing plot data allow to preliminarily set some characteristics of the airplane in the making, mainly in terms of aerodynamics. In addition, the propeller efficiencies can be provided in case we are working with a propeller-driven aircraft. Finally, the sizing plot data tab provides several options for determining the characteristics of the airplane. For instance, in terms of wing area and engine requirement. Thrust can be defined for jet-driven aircraft, and available power can be defined for propeller-driven aircraft. At the top of the sizing plot data tab, you will find a choice box, which provides a choice between 4 different strategies for the setting of the aircraft sizing point. Statistics, which is based on data of existing aircraft. User input, which allows to select a feasible combination of wing loading, or thrust to weight ratio, or weight to power ratio, on the sizing plot. Maximum wing loading, that automatically selects the point on the sizing plot, maximizing the weight over wing area ratio, with the lowest possible engine requirement. Minimum engine requirement, which minimizes the power, or thrust demand, of the engines, trying to achieve the best possible wing loading. Immediately below, in the Data tab, there are 2 secondary input parameters. The first one represents the rating in thrust, or in power, of the maximum continuous setting of the engines with respect to the maximum takeoff rating. The second parameter sets the influence on the performance of the engines of an offset of plus 50 Fahrenheit degrees in terms of ambient temperature with respect to standard ESA conditions. These parameters involve the calculation of climb and takeoff limitations in the sizing plot. The second section of the sizing plot data tab provides the controls to set the aerodynamic characteristics of the aircraft. The user can set the Oswald factors, which determines the shape of all aircraft drag polars, calculated at 4 typically operating conditions: clean, takeoff, landing, and approach. A unique feature of JPAD Modeller as a sizing tool is that the pre-design module allows the user to either set the value of all Oswald factors, or to have them calculated automatically. This second option occurs when the calculate box is checked. This estimation is carried out using a statistical approach, which considers the geometry of the wing and the positioning of the engines, as explained in the window accessible from the Info button. Scrolling down the tab, the user will find a subsection providing the customization of the zero lift drag coefficient increments, due to the deployment of landing gears, to the extension of high lift devices, and to the failure of one of the engines. These values will be also utilized for a preliminary calculation of the aircraft drag polars, related to climb segments limitations within the sizing plot. The user is also provided with the possibility to set the maximum lift coefficients in the following configurations: clean, takeoff, and landing. By checking the calculate box, these input parameters will be set in a semi-automatic manner. By selecting one of the options provided in the choice box immediately on the left. These have been arranged according to 3 levels, corresponding to an increasing performance index of the high lift devices. These values come from available statistics, and depend on the characteristics of the aircraft, in terms of general type, wing aspect ratio and wing sweep angle. Again, these values are used to set the characteristics of the drag polars, as well as the takeoff, climb, and landing limitations within the sizing plot. The final section of the JPAD Modeller Sizing Plot Data tab comprises propeller efficiencies for the takeoff, en route climb, and landing phases. All these fields become available if the aircraft is propeller-driven, and they are used to calculate the climb limitations within the sizing plot.